Well, I just need to close this column. Even though we did this question already, this was the past paper question that we did last class, we're actually going to do it again. You might be wondering why that's just wasting time. Well, that's exactly. Okay, so you know how exam time is coming. Exams are soon. So, during this time, I'll actually share with you how to, practice math. That might sound weird because you would say, I just need to do questions. The more questions I do, I'm good to go. But there's certain techniques if you apply when doing maths, it would actually help a lot, right? So the first one is something called chunking. You see when you do like examples in class, so say we're doing radians now. I do an example in the class. After class, you try to do the example by yourself. So don't look at the solution, you try it yourself. And then if you get in trouble or when you finish, then you look at the solution and you change what you need to change. The next day, you do the same question again. Don't look at the solution, you attempt it yourself. By the next day, so say you practice today, by tomorrow, you'll realize how much easier it is, right? Because as you're doing it, your aim is to understand every single step that you're doing, right? So once you understand all the steps that you're doing over time, so the next day you'll realize, oh wow, this question wasn't as difficult as I thought. That's why we're doing this question again. So I know that we did it Tuesday. I think I'm seeing one new name, but I know Micaiah was here. So don't look at the answer. Just try it now without looking at the solution, right? We're trying this question and then we corrected it. Okay? So I'll give you like 5 minutes. Finish 4 even without looking at the solution. So did anybody get an answer for the first part? They asked me for the area of OACMN, so the whole shape. Anybody got an answer for that? No? Nobody? It's fine, just let me know. So who was here last week? Micaiah, did you get an answer?
Yeah, 16 plus 8. Wait, no, 16 plus 8 pi over 3.
Which part? Part 1 or part 2?
Part 1.
Part 1. What did part 1 ask?
No. Sorry. Wait, yes, this is for the area. 16 plus 8 pi over 3, yeah.
For the area.
Yeah.
Interesting. See, anybody else got an answer that wasn't what Micaiah said? It's not to talk. Nope. All right. Well, let me tell you what the answer is, firstly. So remember we did this already, right? So I might go a little fast for this one. I'll go through the other ones slowly. But this one, since we did it already, and the recording is there, I'll go through it a little faster, right? So the answer for this one, they asked me for the area, not of the sector alone, but for this entire shape, OACMN. The answer was, and they asked me for my answer in terms of pi. So that's why the answer was 8 pi and 3 meters squared. But the thing is, how exactly did I arrive at this answer? Well, to find the area of this entire shape, the shape looks kind of weird.
The answer is 24.3 m.
They asked
Square.
me for it. They asked me for it in terms of pi, so I have to leave my answer in terms of pi. If they didn't say that, then finding decimal is fine. But they specifically said in bold and italics to leave your answer in terms of pi. So this is the final answer. Like I was saying, they asked me to find the area of this entire shape. This shape doesn't look familiar. I don't have a formula where I could use and just substitute the values to find the area of this entire shape. However, I can break it into two different shapes. What do I mean? Well, you see this part up here? This is a sector. I know how to find the area of a sector. I know the formula. So let me just put total area. Total area, so that's the area of the entire shape, is going to be equal to the area of the sector. So I'll just put area of sector. And the area of this square. How do I know that it's a square? Because this is equal to this side, is equal to this side, equal to this side, equal to this. Well, they actually told me that it was a square, right? They said adjoining square. So that's how we know that all the sides are equal. If this length is 4 meters, then this is 4 meters, this is 4 meters, this is 4 meters. So this total area, if I break it up into two shapes, would be the area of the sector plus the area of this square. So let me just write that out. Area of sector plus area of square. We know a formula to find the area of a sector when given the angle in radians. Does anybody remember what formula it is? What's the formula? Anybody?
Half r squared theta.
Half
R squared theta. Remember, this is to find the area of a sector when my angle is in radians. You have a question? Okay. Remember this formula when my angle is in radians. Plus area of a square. We know that the area of a square is side by side. So that's what I put here. All I need to do now is substitute my values. So this is equal to a half r squared. R, which is my radius, is 4 meters. So that's 4 squared. Theta, which is my angle in radians, is pi on 3. Plus side by side. We said that if one side is 4 meters, then all the other sides are 4 meters. Why? Because it's a square. A square has equal sides. So this is 4 times 4. And when you do all of that, you're going to get this answer. Everybody good? If not, let me know. I'll explain again.
yes, miss.
Okay. So Makaya, you understand why now?
Yes, miss, but I'm wondering where I got 16 from then.
The answer that you told me is actually the answer to the second part, where they asked me to find the perimeter. The reason is. Oh, this is taking a while, but I need a diagram. Okay, so that was the answer for the first part, right? If you need a slow explanation, I did it last class. The recording is there. So the answer for the second part, when they asked me for the perimeter, was actually 4 pi and 3 plus 16. Or you could have written it as a single fraction to get 4 pi plus 48 on 3. So either answer is acceptable. They're the same, right? This is what you call mathematically equivalent expression, right? They are the same. So how do I find the perimeter of a shape? Well, to find the perimeter of this shape, I need to add, hold on, let me just erase these lines. To find the perimeter of this shape, I need to add the length of this side plus the length of this arc plus the length of this side, the length of this side, and also the length of this side. That's the definition of a perimeter, right? I know that this is 4 meters. I know that these 3 sides are also 4 meters because it's a square. A square has equal sides. But I don't know this length. I don't know the length of AC. But AC is an arc. We know the formula to find the length of an arc. So let me just put P, the perimeter, would be equal to 4 plus 4 plus 4 plus 4. So let me put that. Plus 4 plus 4 plus this length, AC. But how do we find AC? Does anybody remember the formula to find the length of an arc when the angle is in radians? It's L is equal to something, something. Anybody remembers? Oh my gosh. My bad. But yeah, anybody remembers? If you don't, it's fine, right? Because that was quite Tuesday. But you should be practicing since exams are soon.
L equals R theta.
L is equal to R theta. So all my people sitting exams this year, you should be practicing math, not just art math, right? Your regular math too. You should be trying to practice that every day, even if it's like one question. Yeah, that's very important to do. Because you can't afford to be forgetting things that you already learned months before your exam. So we said that the perimeter is the sum of all these sides. P, you know that this is 4 meters. This is 4 meters. So 4 plus this length, which is 4. This length is 4. This length is 4. However, we don't know the length of this arc. But we do know a formula to find the length of an arc when the angle is in radians. And that's L is equal to R theta, where L is the length of my arc. What is R? Well, R represents the radius. This 4 meters here, this is my radius. Theta is the angle. They told me that theta is pi on 3. So all I need to do is substitute my values. 4 times pi on 3. So let me just add 4 pi on 3. 4 plus 4 plus 4 plus 4, that's 16. You don't need to write out all this. You could just write 4 times 4, right? This is just for explanation purposes. So this is 16 plus 4 pi on 3. But if I write this as a single fraction, I will get 3 on 4 pi plus, well, 48 plus 4 pi. But yeah, same. Everybody good?
Yes.
Yes.
Yes, sir.
If you're not good about any step in this whole solution, let me know, right? I will do it again. Okay, so I'm clearing this off now, right? Okay.
Yes, sir.
The next paper. This is 2013. So I want you to do this one. No, not yet. We do that one, right? But not. Do this one for me. Part 1 and 2. We're not doing B right now, just 4A. Part 1 and 2.